When we first learned derivatives, we learned to take the derivative of basic functions, right? Like power functions, exponential functions, sine, cosine. And then we learned rules for more complex functions, which were combinations of basic functions. So, for example, if we have a composition of two functions, we can use the chain rule. If we have a product of two functions, we can use the product rule. Quotient of two functions, we can use the quotient rule. Now, we also have techniques for computing antiderivatives of more complex functions. And in this last section that we're going to cover in Calc 1, we're going to learn the substitution rule, which is a technique for reversing the chain rule. All right, so first of all, let's revisit the chain rule. We know the chain rule. If we have the composition of two functions, we take the derivative of the outside function, leave the inside function as it is, and multiply it by the derivative of the inside function. So let's practice that technique here with example 1. We're asked to use the chain rule to find the derivative and then write the corresponding indefinite integral. Okay, so if we know the derivative of a function, then we can find the antiderivative. That's what we're getting at here. All right, so this first one we have e to the x squared. All right, now with this function, the outside function is the e to a power, and then inside that we have x squared. So our inside function is x squared. If we use the chain rule, we can find that f prime of x is e to the x squared, and then we take the derivative of that inside function, right? The derivative of x squared is 2x. All right, so there's the derivative using the chain rule. So if we know that the derivative of e to the x squared is e to the x squared times 2x, then we know that the antiderivative, so let me write this down, we know that the antiderivative of e to the x squared times 2x dx is equal to e to the x squared plus c. Okay? So we're going to keep doing that. We're just going to practice that a few more times. We're going to use the chain rule. And now this one, I can see that the inside function is the x squared plus 1. And outside of that, I have a 1/6 times the power function, right? So I'm gonna hang on to this 1/6, and then I'm going to take the derivative of the outside function. So let's see, that's going to give me, bring down the 6, and then we'll have x squared plus 1 to the 5th, right? So I took the derivative of the outside function, that power function, and now I'm going to multiply times the derivative of the inside function, which is 2x. Okay, now this cancels, right? 1/6 times 6, that's just 1. So again, if I know the derivative of this function, then I know that if I know the derivative, I can find the antiderivative of 1/6, not 1/6. I'm going to just make it, we're just going to have x squared plus 1 to the 5th power times 2x dx, right? I know that that antiderivative has to be 1/6 x squared plus 1 to the 6th plus c. Okay? All right, let's do a couple more. These are going to be pretty repetitive here because, you know, you can kind of see where we're going here. We got the same x squared in the as the inside part of the inside function on all of these. So feel free to pause the video, try these on your own. So I'll just go through them. The derivative of ln of x squared plus 4, right? We take the derivative of the outside function, that's the ln. We leave the inside function as it is, and then we multiply it times the derivative of the inside function. Okay? So that tells us that the antiderivative of, and I could write this as 2x over x squared plus 4 dx is going to be the ln, right? ln of x squared plus 4 plus a c, plus c. All right, let's do one more. Derivative of this function, The outside function is sine. Inside of that, I have an x squared minus pi over 2. So the derivative of sine is cosine, right? So I take the derivative of the outside function, leave the inside function as it is, and then I'm going to multiply that times the derivative of the inside function. All right, so that tells us, I know that the antiderivative of my derivative here is, which is cosine of x squared minus pi over 2 times 2x dx. That has to be sine of x squared minus pi over 2 plus c. Okay? All right. Now you kind of see a pattern here, right? we've got a composition of two functions, right? If you look at these antiderivatives, we end up, or sorry, not the antiderivatives, but look at the integrals here. The integrals, we have a composition function, we have an inside and an outside function, and we have the derivative of the inside function in there as well, right? So now we don't want to have to, do guess and check on these integrals. So we're going to learn the method of substitution in the next video.